So I'm Charles Strahan. I'm with Decipher. We just wanted to share a bit of a report on what it was like integrating SPIFFE and SPIRE specifically into our mesh, and how that plays a role in terms of both authentication and authorization. And kind of talk a little bit about the particulars of how we implemented SPIFFE with SPIRE. So just like a high-level overview of what our mesh authentication and authorization looks like. So we support clients connecting, say, like a web browser or another external service outside of our mesh, making a call into our edge, either via OAuth credentials or via mutual TLS. And then once somebody has got the request into our edge via either mechanism, we then secure service-to-service communication as well as edge-to-service using SPIFFE identities. As well, so we can also do on a user level, we can do authentication with JWTs as well. So this is kind of just high-level look at that. And so looking at how we've rolled this out, we're deploying to a Kubernetes cluster, and we use Helm to both set up initial install as well as future upgrades as we roll out new services or make changes to like RBAC policies, et cetera. We use SPIRE to manage rotation of certificates as well as the initial deployment of them. We use Envoy as our sidecar, and it is what terminates our mutual TLS. And we maybe an interesting note for those who are familiar with Envoy, we actually have a custom fork, which is sort of an interesting novel note there. We've extended it to be able to implement filters in the Envoy jargon in Go. So if anybody is also interested in that, can feel free to ping me. I gave my email earlier on the first slide there. And so we have implemented in Envoy via the Envoy configuration. Envoy has really great filters baked in for doing things like RBAC. And so you can create policies around which principals are allowed to communicate to various services. So you can lock down which services can talk to each other if you're trying to implement some sort of zero trust networking environment, as we are. You can also do things like do JWT as well as a number of other authentication and authorization policies. Looking at kind of to steal a graphic to kind of give a visual to what this looks like, although granted, this is it's a little bit different than how we have things set up right now. We're trying to move a little bit more towards what is exactly shown here, and I'll kind of talk about that a little bit later. Although some of the names or some of the particulars have changed. Spire KS Bridge, for example, has been subsumed by another project, but I can talk about that a little bit later. But this does give like a decent sort of graphical view at how all the components come together for us. We have our typical Spire setup. We have a Spire agent, Spire server. All of that is handled through Kubernetes. Here in a moment, I could talk about how exactly we handle initial registration of the various workloads, the identities thereof, and some of the more specific details of how all this comes together. For us, what we're doing right now is we have a Helm chart, which we have a bit of a template to collect all of these service names for all these services that we are deploying. And we collect that into one config map, which is at the end of the day just going to be materialized as a file on the file system of the respective node, for those who aren't familiar with the Kubernetes lingo. But the idea is that we sort of materialize this config file with all the known services, and then with Helm, we deploy the Spire server as well as a little side bootstrapping script that goes through all of those service names that we have written out, and then it registers those services via the CLI. And so some future work for us, because some of the downsides there to doing exactly what I described is that as you spin up the Kubernetes cluster, say fresh, everything works exactly as you would want it to. All the services that you had declared up front, there's going to be spat out into the config map, and then that gets loaded up, and all that's great. But as you do an upgrade, or you deploy new services, or you pull services out of the rotation, then these known services are changing over time, and we don't really have a good way with a sort of static approach to doing this once in a stateful set in Kubernetes. We don't have a really good way to immediately respond to that change in the known services. But this has been like a great way for us to experiment and get set up very quickly. So it was nice that that was available as a strategy. So future work, as described down below, we want to look into the Kubernetes workload registrar, which is that component that I talked about earlier, subsuming the bridge. And the idea is that you could have a sort of reactive approach to registering or unregistering services. So whenever you would say do a Helm upgrade or whatever other means you might use to deploy services to your Kubernetes cluster, as those new services or deployments come into existence, as Kubernetes becomes aware of them, it can then, through a webhook, notify another component that's waiting to automatically handle all of that on your behalf. So that would take out the sort of latency and a little bit of handholding that we would have to have right now to add new services as time goes by. I'd like to talk a little bit about specifically what plugins we are using for attestation. So we use the K8s SAT plugin, which gives us a way to verify the authenticity and whether or not a particular node is authorized, for that matter, to be interacting with the Spire server. And then we use the K8s plugin for the workload attestation. And so the basic idea is, drop a Unix domain socket into the container. Sidecar, in our case, Envoy, connects to that. And then this plugin will manage figuring out credentials through starting from the user ID of the sidecar phoning in. We're looking at switching, going back to the K8s SAT, we're looking at switching that over to the PSAT variant. Kubernetes is very much a learning process for myself, and so we realize we can have a little bit more security if we use that, because the idea is that tokens still become these, they become shorter lived. You can put an expiry on it. You can kind of tighten things down a little bit more. So that is something that we're actively looking into, switching from the K8s SAT plugin to the PSAT, which is the projected service account token volume plugin. And then I just have a little bit of a graphic that really only a little bit this talk really touches on directly, which is the relationship between the node agent and the workload plugins, et cetera. But probably what's more interesting is just a little glimpse into a sort of dummy example of how we can implement RBAC policies in Envoy. Here's a little chunk of YAML that would be part of our Envoy configuration, although granted, we actually do this through the XDS APIs in Envoy. For those who are familiar, you can actually push configuration to your Envoy instances. But this is what the YAML representation of that would look like. And so the idea is, imagine everything in the little mustache kind of curlies is templating here. You can say that some other external workload, where I have workload name, is permitted to do any sort of get, update, put, etc. To any arbitrary URL for the sidecar if they are this exact particular principal with, corresponding to that workload that wants to access us as a resource. And so that's pretty much, I believe that's all I have. I was probably getting pretty close to the end of my time as well. So I guess with that, I can answer any questions if anybody's curious about some of the particulars of what we're doing.
Anybody in the room? I don't have any hands up.
Oh, that
we got one.
Excellent communicator.
I've got a question.
Okay,
So,
cool.
and this is mostly about your Envoy deployment. Are you authenticating the config pushes over the XDS, or is that in a pod so it doesn't have to be authenticated?
That is actually a good question. So we are certainly, it is our end goal that everything be authenticated end to end. I forget about the particulars of how we push the XDS messages. I believe that we have sort of a bootstrap cert /CA approach to handling that so that it is currently encrypted. But I also don't want to misspeak. But that's kind of the idea that we're going for.
Cool, thanks.
Sure.